Hi there and welcome to another video from Faraz, the GCSE Maths mentor. Welcome to another video on straight line graphs part 2. Now before we begin, quick question. Did you watch part 1? If not, hit pause and go back to watch that first because this video builds on everything we did there. In straight line graphs part 1, we practiced plotting coordinates using tables of values. We saw how we could substitute different values of x into an equation and plot the corresponding y values on the grid. So if you are already confident with that, brilliant, you're in the right place. Okay, let's start with the first question. Complete the following table and plot the resulting graph. Pause the video and try this question by yourself. Alright, let's solve each and every table one by one. So let's start with y equals to 3x, x equals to negative 3, y equals to 3 times x, which means y equals to 3 times negative 3. And that would give you 3 into negative 3, negative 9. So we must write there negative 9. Then y equals to 3x, 3 times 0, that would be 0 there. Y equals to 3x, 3 into 3, that is 9. Alright, let's solve this one. Y equals to 3x plus 2. So y equals to 3 times negative 3 plus 2. And that would give you negative 9 plus 2, which means negative 7. So therefore we have to put negative 7 there. Y equals to 3x plus 2 means y equals to 3 times 0 is 0 and 0 plus 2 is 2. So that would be 2 there. And y equals to 3 into 3, this, which means 9. 9 plus 2, 11. 3 and 11. Let's do the third one, 3x minus 6. So y equals to 3 into negative 3 minus 6. 3 times minus 3, minus 9, minus 6. Two negative numbers always add with each other, negative 15. So therefore we have to put negative 15 there. In the second one, y equals to 3 times 0, which means 0 minus 6. So that would be minus 6 there. And y equals to 3 times 3, which is 9. 9 minus 6, that must be 3. Alright, let's plot the first line y equals to 3x by the blue color. So here we have coordinates minus 3 comma minus 9. So it has to be there minus 3 comma minus 9 at this place. And 0 comma 0 must be at the center. And 3 comma 9 on x-axis, look for 3 and then move up till 9 here. Join them together. Alright, that must be the line of y equals to 3x. Then we have to plot y equals to 3x plus 2. The coordinates are already there, negative 3, negative 7. So we need to first plot negative 3 and negative 7. And let's plot this one by red color. So negative 3 and negative 7. Negative 3 comma negative 7, it must be there. Then we have 0 comma 2. 0 is at the center, x is 0 at the center, and from 0 we have to move up to 2 units like this, and 3 comma 11. From 3 we have to move up till 11 there. Alright, now if we join these coordinates together with the help of a line, so this red line is y equals to 3x plus 2. Let's draw this one by a green line. Y equals to 3x minus 6. So the first coordinate is negative 3 and negative 15. Negative 3 and negative 15, it must be there. And then after this we can say 0 comma negative 6. So 0 comma negative 6 is there. And finally we have 3 comma 3. 3 comma 3, it must be there. Alright, join these coordinates together. So this green line is y equals to 3x minus 6. Alright students, brilliant work so far. Now let's take a step back and look at what's happening on this final graph. We have plotted three different straight line equations. The blue line y equals to 3x, the red line y equals to 3x plus 2, and the green line y equals to 3x minus 6. Notice how all three lines have the same gradient. They are all sloping upwards at the same angle. That's because the coefficient of x is 3 in every equation. See, the coefficient of x is 3 in every equation. The gradient is 3 for all of them. So what's changing is the y-intercept, the number added or subtracted at the end. In the first one it is 0, in the second one it is plus 2, and in the third one it is negative 6. The blue one crosses at 0, the red one is shifted up by 2, so it crosses the y-axis at 2, and the green one is shifted down by 6, crossing the y-axis at negative 6. This shows how adding or subtracting a number on the end of a linear equation moves the line up or down, but the steepness, the gradient stays the same. So these all lines, blue, red and green, they all are parallel to each other because the gradient are same for all of them. Final tip, if you ever see equations like this in an exam, check the coefficient of x for the gradient and the constant number for the y-intercept. Alright, next question. Pause the video and try this question by yourself. Okay, so let's start with the first one, y equals to 5x. X is negative 3 there. So if you do y equals to 5x, which means 5 times negative 3, and that would be negative 15. Y equals to 5x means 5 times 0, which is 0 there. Y equals to 5x, it means 5 times 3, that is 15. Alright, let's do this one. Y equals to 5x plus 6. It means you have to do negative 15 at 6. Negative 15 at 6 means subtraction. So 15 minus 6, that would be 9 with the negative sign. 5 times 0, that would be 0 plus 6. Therefore, that is 0, 6. And then 5 into 3 is 15. 15 plus 6, that is 21. Alright, let's do the third one. Y equals to 5x minus 11. 5 into negative 3, that is negative 15. Negative 15, negative 11. We need to add them together. Negative 15, negative 11, that is negative 26. 5 into x is 5 times 0 is 0 and then negative 11 only. And then 5 into 3 is 15 and 15 minus 11, that is 4. Now it's time to plot each and every line one by one. So let's plot the first one. Let's make it in blue color. Alright, we have to plot the coordinates first. Negative 3 comma negative 15, it has to be there. Then 0 comma 0 must be at the center because center is the origin in which x and y both are 0. And then we have 3 comma 15. 3 comma 15, it has to be there. Now we need to join them together with the help of a line. So this blue line is y equals to 5x. Then we have to plot the coordinates of the line y equals to 5x plus 6. Let's make them in the red color. So negative 3 comma negative 9, it has to be there. Negative 3 comma negative 9. 0 comma 6, it has to be there. And then 3 comma 21, 3 comma 21. Okay, we can't plot that coordinate 3 comma 21. So because 21 is not in the range, but don't worry, we can also plot a line with the help of two coordinates. So let's join them together with the help of two coordinates. So this red line is y equals to 5x plus 6. Let's plot the last one with the green color. So the coordinates are negative 3, negative 26. So you can't plot negative 3, negative 26. But you can plot 0, comma negative 11 and 3, comma 4. So 2 points are enough to draw a line on the grid. So 0, comma negative 11. Let's plot it. 0, comma negative 11 must be there at this point. And then we have to plot 3, comma 4. 3, comma 4 must be there. And then you can extend the line on the grid. So this green line is y equals to 5x minus 11. Alright, now take a look at this. We have got three straight lines, blue, red and green. All of them have the same gradient of 5, so they are equally steep. That's why the lines are parallel to each other. But what's different is their y-intercepts. That's the point where each line crosses the y-axis. The blue line y equals to 5x goes straight through the origin. The red line y equals to 5x plus 6 has been shifted up, and the green line y equals to 5x minus 11 has been shifted down. So even though the lines have the same slope, they all sit at different heights. That's the power of the plus c part in a linear equation. It tells you where the line starts on the y-axis. This is a brilliant way to visualize how changing the intercept moves the whole line up or down without affecting its steepness. Alright, let's quickly understand the straight line equation from this graphing tool. So the first thing here, we have to put y equals to mx plus c there, and then add m as a slider and add c as a slider. Just make them equals to 0 and 0. So what you're seeing here, when we are substituting m as 0 and c is 0, it will look like this: y equals to 0x plus 0, which means that y equals to 0 plus 0, that is 0. So that is the line of y equals to 0. This is a perfectly flat horizontal line that lie on the x-axis, no slope, no rise, just sits flat. Every x value gives you y equals to 0. Let's say if we plot this coordinate, that is negative 6 comma 0. This one is 8 comma 0, in this way. Alright, let's talk about another case. M as 0 and c equals to 3. So you can see there, that is a equation of y equals to 3, because m is 0 there, so that would be 0x plus 3, therefore y equals to 3. And y is equals to 3 is still a flat horizontal line, but this time it sits above the x-axis. Every point on the line has y equals to 3, no matter what x is. So lesson, when m equals to 0, you always get a horizontal line, and c just tells you where it's sitting vertically. Alright, the next case is m equals to 1 and c equals to 0. So this line goes through the origin 0 comma 0. Here we have the origin. At the center it is 0 comma 0. X is 0 there at the center and y is 0 there at the center, and rises at a perfect 45-degree angle. For every one step to the right, the line goes one step up. So m equals to 1 is your standard rising slope. Alright, let's talk about the case 4 when m is 1 and c is 2. Now this time the equation will look like this: y equals to m is 1, so 1x plus 2, or y equals to x plus 2. Same slope as before, but this time the line starts higher. It now crosses the y-axis at 0 comma 2. Gradient stays the same, but intercept changes, means vertical shift upward. Alright, let's talk about case 5 when m is 2 and c is 1. Alright, so now your equation will look like this: y equals to 2x plus 1. Here the line is steeper than m equals to 1. It rises faster from 0 comma 1. So here it is from 0 comma 1. Every step forward takes us 2 steps up. That's a sharper climb. The bigger m gets, the steeper the line becomes. Alright, next case. When m is equals to 5 and c equals to negative 3. So the equation will look like y equals to 5x minus 3. Now we are looking at a very steep rising line starting below the x-axis at y equals to negative 3 there. This is a dramatic climb, super steep. If you see a large positive m, accept a rocket-like rise. Now negative m, falling lines. So when m is negative 1, like this, and c equals to 0. So now the equation will look like this: y equals to negative 1x plus 0, which means y equals to negative 1x or y equals to negative x. So this is the opposite of y equals to x. The line passes through the origin, but now it falls from left to right. For every step forward, the line drops 1 unit. Now let's talk about case 8 when m is negative 2 and c equals to 3. So the equation will look like this: y equals to minus 2x plus 3. Now it falls twice as fast, starting from y equals to 3 there. This is a steep negative slope. The bigger the negative gradient, the steeper the descent. Alright, let's talk about case 9 when m is negative 5, like this, and c equals to negative 1. So your equation would become like this: y equals to negative 5x negative 1. Now we have a very steep downward line starting below the x-axis. This line show rapid decline, steep negative gradient plus negative intercept. It's a dramatic drop. Alright, finally let's talk about a special case. So when you have m as, let's say, undefined or a vertical line, how the gradient will look like. Let's say if I draw the line of x equals to 4, this is not written as y equals to mx plus c, it is just x equals to 4. This line is just x equals to 4. Why? Because on this line, each and every coordinate has x equals to 4. Let's say if we have this coordinate, it is 4 comma 2. This one is 4 comma 4. This one is 4 comma 6. Y's keep changing, but x will remain constant there. So this is a vertical line, and here the gradient is undefined because the line goes straight up. Straight vertical lines aren't functions in the usual sense because they fail the vertical line test, but students should know they exist. And let's say if you find the gradient of the vertical line, you can do m equals to y2 minus y1 over x2 minus x1. Let's say this one 4 comma 2 and 4 comma 4. Let's say this one is x1 y1 and this one as x2 y2. It is up to you. You can take any coordinate x1 y1 and x2 y2. So y2 is 4 there, minus y1 is 2 and x2 is 4 there, minus x1 is 4. Now you can see there we will have 2 over 0 and 2 over 0. This means it is undefined. That's why we are saying that the gradient of the vertical line is undefined. Alright team, let's pull everything together with a clear summary of how straight line graphs work. We are dealing with the equation y equals to mx plus c. Now what does that really mean? First, the c, that's your y-intercept. It tells us exactly where the line cuts through the y-axis, the vertical axis. And here's a golden rule. The value of y when x equals to 0 is always your c. Let me repeat it. The value of y when x equals to 0 is always your c. So if the line crosses at 6, that's your c value right there. Quick tip from me, just glance at the y-axis. Where your line hits it, that's your intercept. Next is m, and this is where the magic really happens. M is your gradient, also called the slope. It shows you how steep your line is. For every one step across on the x-axis, the gradient tells you how many steps up or down you go on the y-axis. Easy tip time. If m is big, your line will be super steep, shooting up quickly. If m is small, the line flattens out. If m is negative, watch out, the line heads downhill. So just from looking at m and c, you can sketch or understand any straight line graphs instantly. This right here is what separates average students from brilliant ones. Mastering y equals to mx plus c is like holding the blueprint to every straight line you will ever see. Alright superstars, let's have a go at these basic level questions and I will walk you through each one step by step the proper GCSE way. We are identifying m, the gradient, and c, the y-intercept, just like we talked about. Y equals to 2x plus 4, part A. This one's already in perfect y equals to mx plus c form. So m is 2 there and c is 4. So you can write it as y equals to mx plus c, and therefore m is 2 and c is 4. This means the line goes up 2 for every one step across and it crosses the y-axis at 4. Okay, let's move to the part B. Y equals to minus 3x plus 1. Again, it's already in mx plus c form. So m is negative 3. Y equals to mx plus c. M is negative 3 there. And c is equals to 1. Y equals to 5x. Alright, let's move to the part C. Y equals to 5x. There's no number added at the end. But don't worry, that just means the y-intercept is 0. So you can write it as 5x plus 0, and if you compare it with the form y equals to mx plus c, it means that m is 5 and c is 0. M equals to 5, c equals to 0. This line goes through the origin and is quite steep. Alright, let's move to the part D now. Y equals to 6 minus 2x. Well, looks like a little sneaky. Let's rewrite it in the standard form mx plus c. So we reorder it as y equals to minus 2x plus 6. Okay, be careful in these type of question. You have to rearrange them first. And then now it's clear that m is negative 2, y equals to mx plus c. M is negative 2 there and c is 6. The last one, y equals to negative 4 plus x. Again, let's rearrange to y equals to x minus 4 plus x and then minus 4. Then compare it with the form y equals to mx plus c, which means that now there is nothing in front of x. It means it is 1, which means that m equals to 1 and c equals to negative 4. Whenever you are stuck, always aim to rearrange into y equals to mx plus c form. Once you do that, spotting m and c becomes super easy, like second nature. Keep going, you're smashing it. Alright champions, let's now level up. These intermediate questions need a little more brain power, but nothing we can't handle together. We are still after m and c, the gradient and the y-intercept. Let's go one by one. Y equals to 4x minus 2. Already in the perfect y equals to mx plus c form. So I can just write there y equals to mx plus c, and if you compare that form, m is 4 there, c is negative 2. M equals to 4, c equals to negative 2. In part B, y equals to 5 minus 3x. Well, this one looks a bit shuffled. Let's tidy it up into mx plus c form. So y equals to, first we have to rearrange it in the form mx plus c. We have to write minus 3x first, then plus 5. Compare it with mx plus c now, which means that m is negative 3 and c is positive 5. This line slopes downward and it hits the y-axis at 5. Now part C, 2y equals to 6x plus 8. This one needs a little rearranging. Let's divide everything by 2. So if you divide both sides by 2, 2y divided by 2 equals to 6x divided by 2 plus 8 divided by 2. It will give you y equals to 6 over 2 means 3x plus 8 over 2 means 4. Now it's easy. M is 3 and c is 4. Y equals to mx plus c. M is 3 and c is 4. M equals to 3, c equals to 4. In part D, y minus 7 equals to 2x. This one's sneaky. Let's add 7 to both sides. So y equals to minus 7 plus 7, that would be 0 here, and therefore 2x plus 7. And then m is 2 there and c is 7. Y equals to mx plus c. M is 2 there and c is equals to 7. The last part, part E, 3y plus 6x equals 12. Bit of a twist, we have got to solve for y. Step 1, subtract 6x from both sides. So if you do that, one step at a time, 3y equals to 12 plus 6x minus 6x will be 0 there on the left side, 12 minus 6x. And then you have to divide everything by 3, divide 3 on both sides. 12 over 3 minus 6x over 3, which will give you y equals to 12 over 3 means 4 minus 6 over 3 means 2x. Now it is y equals to 4 minus 2x. So Then we have to write negative 2x first and 4 after it. Negative 2x and then we have to write 4. Compare it with y equals to mx plus c, which means that m is negative 2 and c is equals to 4. Alright, my brilliant learners, we are stepping into exam territory now. These are the advanced questions, the ones that often look scary, but not for us. We will take each one and calmly rearrange into the golden form y equals to mx plus c. Let's begin. Part A, 3y minus 6x equals 9. Let's get y on its own. Step 1, add 6x to both sides. So we will write 3y minus 6x plus 6x is 0 on the left side. 3y equals to 9 plus 6x. Now divide everything by 3. If you divide everything by 3, that would give you y there on the left side. 9 over 3 is 3. 3 plus 6 over 3 is 2. 3 plus 2x. Rearranged it, it will give you y equals to 2x plus 3. Therefore, the answer is for m, y equals to mx plus c. For m, it is 2 there, and for c, it is 3. Pause the video and try part B by yourself. Alright, let's do part B now. 2y plus 4 equals 10x. Let's subtract 4 on both sides. So it will give you 2y plus 4 minus 4 will be 0 there, equals to 10x minus 4. And then divide 2 on both sides. You will get y equals to 10 divided by 2 is 5, 5x minus 4, 4 divided by 2 is 2. So it means that m equals to 5 and c equals to minus 2. Pause the video and try the part C by yourself. So first we have to subtract 5x both sides. It will give you 2y equals to 5x minus 5x 0 there on the left side, and it will give you 8 minus 5x, or simply minus 5x plus 8. You can also write minus 5x plus 8. Then dividing 2 on both sides, it will give you y equals to minus 5 over 2 x plus 8 over 2 means 4. Therefore, m is minus 5 over 2 and c equals to 4. The second last, 7y equals to 21 minus 14x. Pause the video and try this one by yourself. Let's tidy this one first. We have to flip it to the line. We have to flip it to line up x first. So that would be 7y equals to minus 14x plus 21. Then you have to divide 7 on both sides. So it will give you y equals to 14 divided by 7 is 2 there. So minus 2x plus 21 divided by 7 is 3. Minus 2x plus 3, which means m equals to minus 2 and c equals to 3. Alright, the last one, part E. Let's move it to there. Alright, this one's a bit messy. First subtract 6 from both sides. So we have this minus 2y. As you do 6 minus 6, that would be 0 there on the left side. So 4x minus 6. Then we have to divide minus 2 on both sides. It will give you y equals to 4 divided by minus 2, that would be minus 2x. Minus 6 divided by minus 2, that would be plus 3. Whenever we divide two negative numbers, the result is always positive. So therefore, m is negative 2 and c equals to 3. So top tip, don't panic when the equation is in need. Just follow the same step, isolate y, then simplify, and everything falls into place. And remember, the examiner might mix it up, but you have mastered the core idea. You are flying now, let's keep going. Struggling with maths, or maybe you just need a boost to move up a grade or two? Well, imagine learning with a mentor who truly gets how to explain things simply and make them stick. Hi, I am Faraz, your dedicated GCSE and A-level maths mentor. In my live online group sessions, you will learn smarter, not harder. Get exam hacks, topic breakdowns, and real practice with past papers. All for just £4 per hour for GCSE, £5 for AS level, and £6 for full A-level maths. And don't worry, you will never be lost in a crowd. I keep class sizes small, max 10 students, so you always get noticed, supported, and understood. Message me now on WhatsApp to grab your spot before the next group starts. And what I'm about to share next might just make the biggest difference to your exam prep. And here's the exciting part. When you join my group classes, it's not just an hour-long lesson. It's a full math success system. You'll get 12 live group sessions each month, free revision resources tailored exactly to your syllabus, targeted exam style questions, and past paper walkthroughs, topic wise practice packs to boost weak areas, and one on one support whenever you are stuck. But wait, there's one more thing I'll tell you, something that sets my students apart from the rest. But you will have to message me for that. I promise it's worth it. WhatsApp me now. The number is showing on screen, and let's finally turn maths into your strongest subject.